Alright, this is a follow-up to the little high voltage, tank circuit that I demonstrated in another video. And, one of the things they don't ever mention, they always talk about, series resonant circuits, you know, like you see here, generating a high voltage, at this point, especially if they have high Q coils and so forth. And the Q of a coil, is its reactance to its resistance at its resonant frequency. So, if it has a low coil resistance like this does, it's probably in the milliohms going into a reactance of perhaps, 500 ohms or so at that resonant frequency. That's a high Q. So, but what it means is the ability of the inductor to store energy is much higher because it's got a lower resistance, so more current can flow through it. And the current through an inductor, the energy in an inductor, is basically 1/2 Li squared, right? And the energy in a capacitor is 1/2 CV squared. Now, if you get a decent amount of energy, it doesn't have to be that high, stored in here. It's gonna be fed into this capacitor eventually, and you solve for the voltage, using algebra, and that tells you what voltage it'll charge up to. It's just strictly amount of energy. If you have it up to a certain known current going through it, you know what the energy is, you know what the inductor value is, and so forth. But anyway, the point is it's kind of an important safety message, if nothing else. It's not just a video about cool and interesting properties of inductors and resonant circuits. It's about, how this thing, since you never read that, I've never, in all the textbooks I've ever looked at, I've always seen warnings about series resonant circuits generating high voltage, but never parallel, not tank circuits. So I thought basically, they were incapable of that. Well, no, apparently they're not. That's what my video proved, is that I showed it in action. And believe me, I could have generated a lot higher voltages than that. But since I was limited to 100 volts, I didn't want to damage that. And I sure didn't want to damage my oscilloscope or power supplies or DMMs or anything else I might have hooked to it. Because that can happen. And like I said, a lot of people will see, resonant tank circuits, um, like I'll show you in a minute. Let me see if I can find one real quick. But yeah, if you find a tank circuit, in a textbook, and you say, I want to see this cool oscillation die off here. So you end up, grabbing something out of your junk box and fiddling it together. Well, you could get the shit shocked out of you if you use the high Q inductor and everything. I mean, you don't know. You're new to electronics and just want to see something on your little, oscilloscope that you bought from Amazon or whatnot, like one of these, and you end up not only blowing that out, but getting a bad shock, and and if it's a big enough inductor, it could even be lethal. But at the very least, because this, the insulation on a lot of these things will be 1500, 2000 volts easily. So before the inductor would fail, so it can generate a pretty high voltage, and if you got 1 or 2 amps flowing through it, it's going to make 1 or 2 amps flow through you if it gets a chance, potentially at a very high voltage. So, my point is that especially if the capacitor can't handle it, etc. I mean, it could generate dangerous voltages. Inductors always can, even if you're not using it as a tank circuit. But just because it's a tank circuit, you may get the impression that they're safe because no textbook ever talks about tank circuits generating high voltages. Well, I'm saying under certain circumstances they can, and at the very least it could damage a lot of equipment. So, you know, so it's just something to be aware of. And I don't know how useful that circuit is as a like a high voltage generator or anything. It is kind of nice because you can use the capacitor itself, to actually determine what voltage the thing puts out as a peak voltage. So because of that, and it's not a function of the turns ratio or anything, but you can select the right capacitance value to produce a high voltage of predetermined fashion, and it's going to resonate at the resonant frequency, so you know what kind of frequency it's going to produce but you can also determine what the worst case peak to peak voltages will be. So because of that, that's a little unique because again, you don't actually have to use a transformer. I mean, this is a three-terminal inductor, and I'm using two terminals of it. So in fact, that's actually a higher inductance terminal apparently. But my point is, it does have that advantage, that yeah, you can actually set the damn voltage limit of the thing based on the size of that capacitor as long as you do your due diligence, make sure the capacitor can handle that voltage, make sure it's not so high the inductor's windings will break down, and be cognizant of what you have hooked to it to do this. Your FETs or other transistors, are they going to blow out? Because of that, and what equipment you're using, what settings you have it at, and what kind of probe you have hooked to it to make sure it's not going to damage your equipment. Because who knows, your math could be wrong or something could go wrong after that solder joint broke. This will produce the maximum voltage it can before it blows out the windings, no matter what that is. Even if you're expecting 200 volts, it might generate 2,000 volts. Okay, and actually damage an expensive inductor, especially if it's a high Q inductor. Yeah, it might set you back, $30 or more. So, as well as maybe having to buy a new oscilloscope or, spectrum analyzer you might have hooked to this. Oh, God forbid. So, let alone like an analog discovery or something. I mean, who'd want to replace a $400 analog discovery? Well, like I said, again, I got lucky on getting that off eBay. But holy shit, I'd hate to have to replace that, because this is producing high voltages. So even a 10x probe will still only protect you 10x, and then still if you're dealing with high enough voltages, that won't be enough because I promise the voltage rating of 10x probes doesn't include, kilovolt level voltages in all likelihood. Well, that might. I guess it depends on how they're rated, safety rated. So I don't know. But anyway, I wouldn't want to take a chance either way. So my point is just an important safety message. It's nothing else, but beyond that, it's an interesting phenomenon. Maybe a useful circuit, depending in a weird kind of way, depending on if you have an application for something like that. Where you can actually predetermine what the voltage is, no matter how much current you leave on it. Because you saw, I mean, I could leave current on that thing for several minutes. I mean, I could just leave it sitting there for an hour if I wanted to, and then remove current, and it'll do the same thing. It'll generate the same voltage regardless. That is the maximum voltage it'll produce as long as everything's hooked up right and nothing fails. All right, it's the maximum voltage that would produce. Is what you calculate. So it won't be higher than that. Whereas a transformer, geez, who knows? It might go higher. So there is that. It might be useful in that respect. I don't know, but still, it's an important safety note to be aware of anyway. That's something you think because you don't see a warning on it in a textbook, you don't think it'll hurt you when it could, and at the very least, it could hurt your equipment. So be cautious. Cheers.